In this section, we're going to take a look at an application of a standard form equation. So let's say we have Paul has two savings accounts invested for his retirement. In one account, he has $210,000. $210,000. And in the other account, he has $330,000. So he has two savings accounts for retirement, and they have this amount in one and this amount in the other. All right, after calculating his living expenses, or his estimated expenses, he's going to need to earn $40,000 in annual investment income. So he needs to earn $40,000 per year to live off of. We want to write an equation in standard form that describes this problem. Now, if Paul earns 12% interest in his first account, he earns 12% interest in his first account, how much interest does he need to earn in the second account in order to have an annual investment income of $40,000? So we want to know what percent interest that he needs to earn in this account in order to have this amount of money for each year for his retirement. Okay, so let's remind ourselves what a standard form equation looks like. We have AX plus BY equals C. Okay, this is our standard form equation. So let's go ahead and label some variables that we're given. We're given $210,000 and $330,000. So we have two numbers multiplied by two numbers to give us this number. So we can write this as 200. Let's go ahead and label our variables first, getting ahead of ourselves. We're going to say A equals the first account, $210,000. And we can say B, label our variable B as $330,000. That's the amount in our second account, or in Paul's second account. And we want to know C. C is the total annual interest earned. We want it to be $40,000. Okay, so this is going to be the total investment earned, or let's just say $40,000. I'm going to earn $40,000 per year. All right, so that means X is going to be 12%, or 0.12. Okay, it's going to be the annual interest earned on this account is going to be A times X, or $210,000 times 12%. All right, and Y is going to be the interest earned on the second account. This is actually what we don't know. We need to know the interest earned on this account in order to finish up our standard form equation. So let's plug in and solve for Y. So we have our standard form equation. Let's go ahead and fill in our variables. We have A, which is 210,000. Let's just drop the dollar signs for right now, times X, which is 12%, or just 0.12, plus BY. B is 330,000. That's the amount in our second account, times Y. Y is what we want to solve for, and we want this to equal C, which is $40,000. So $40,000 on the right-hand side. Let's go ahead and combine these two terms. That'll give us 210,000 times 0.12 is 25,200. And we can rewrite the rest. We're just simply solving for Y, which we know how to do. 40,000. Okay, so we want to isolate our variables. So let's subtract 25,200 from both sides, which gives us 300,000 Y. 40,000 minus 25,200, believe will give us 14,800. That sounds about right. 14,800. And we can finish up by dividing both sides by 300,000. So Y equals 14,800 divided by 300,000. I like to line up our digits here so we can see some easy cancellations. We have a cancellation of these zeros, and this ends up with 0.0448. Or another way to write this as 4.48%, since we want to know the annual interest earned on this second account B. So we can say that Paul will need to earn 4.48% on the second account, this $330,000 account, to meet his annual expenses of $40,000 a year. This is a very good application of an equation in standard form, and it's actually used quite extensively in finance and investments. So we want to get a good handle on this using our standard form equation and plugging in the appropriate variables. Like always, when we convert a word problem to an actual equation, that's the most crucial step, because by now we should be able to fly through this and solve for a given variable. So let's just practice a few more of these. I'll see you in the next video.